Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm chatting with Jose Tejada. He's also known as JOTEGO, J-O-T-E-G-O, on Patreon. How are you, sir?
Very well, thank you. How are you?
I am very excited to chat with you because I'm a huge fan of your work and I've supported your Patreon for quite a while.
Thank you.
You are creating FPGA cores as a digital archivist of sort. You are enabling us to run old hardware on new hardware. And I think that that's just amazing work.
Thank you. Yes, that's exactly what we are trying to do. We are trying to archive the old hardware using hardware.
You are archiving old hardware with hardware. That's amazing. So I've loved emulators for a very long time, and MAME, the multi-arcade machine emulator, is a software emulator that can take that old software and run it on really fast machines. Like in order to emulate an arcade game or even a Game Boy, I would need a whole PC to do that. But FPGAs, field programmable gate arrays, are changing the emulation game. What are FPGAs and why are they changing emulation as we know it?
So FPGAs are integrated circuits that contain a bunch of generic digital logic. Basically, they contain registers that can hold either a 1 or a 0, like they are like 1-bit memories. And then in front of each one of these memories, they contain like a little RAM where you can program a lookup table. So depending on the inputs, you get a different output. So that's the two pieces you need to make any digital logic. You need some combinational logic, and that's the lookup table. And then you need some bit memory, and that's your register. So those are the building blocks that you need to build like any digital circuit.
These FPGAs, they're not like computers. They are programmable arrays of gates. But are they little PCs? They're not ARM CPU. Do they have CPUs, or are they just empty and you have to make them become CPUs?
Yes. What they call the FPGA fabric itself, it's empty. It's just logic with switches, and what you program is these switches. So you program, what register is going to connect to which other register, and then you program the logic functions inside these small lookup tables. But you can convert that into a CPU, you can convert that into a DSP. They are typically used to process cell phone microwaves in stations. So that's like the most common use for them. So they are full of multipliers because you need to multiply a lot of signals. And some of them come with a side ARM CPU. So if you look at the die shot, you have the FPGA fabric, and then sitting beside it, there is like a real CPU. By real, I mean not built with FPGA fabric, but built directly using CMOS technology.
So almost a sidecar CPU that's along for the ride in case you need that available. And
yes.
When do you think FPGAs were discovered for emulators for this kind of work? Because as you said, they've existed in signal processing for a long time. Prototypers have used them. But at some point, someone said, hey, I could make a 1976, asteroids game on this thing. And then it just blew up.
Yes, you actually see them on actual arcade boards from the time. Like the arcade boards usually have custom graphic chips. They normally do it using what they call it something like gate array something. It's like the ZX Spectrum, where there is a chip that was like generic, shared by a lot of people, but the final metal layer where you connect the different things, each user could change that metal layer and could make something different. And they were using that type of technology. Like Konami used that a lot. And that's good, but it is not as flexible as an FPGA. But at some point in the maybe early 90s, FPGAs were making their way there because you were able to make custom logic when you were not going to make like millions of chips, but maybe only a few thousands. So it was there all the time, but for me, I discovered it with the MiST project that was trying to make an Atari ST and a Commodore Amiga on an FPGA. So that was my first contact with this platform.
And the MiSTer, MiSTer, MiSTer project, or the MIST project, is a whole team of folks that are making these open source emulators for consoles, for computers, for arcade boards, with FPGA at the core. And as you point out, FPGAs, they were been around since the mid 80s. There was a big growth in the mid 90s, and then MiSTer kind of came on the scene. It's said maybe around 2020 or 2021 that like MiSTer would be the device to rule them all, and this was going to be the end of emulation, in the sense of now we don't try to get clock accurate emulation on a PC. It's too many variables. What is it about FPGAs that make them quote unquote perfect? Like it's the perfect emulator because it's not emulation. It's really clock perfect. I'm not sure if I'm saying that correctly.
Yes, that's correct. It's like potentially, it all depends on, on whether you have the information and you have the developer applying the information, but potentially you could replicate all the signals. You could get, all the critical signals to be as exact as you want, down to one clock cycle, which in these systems, clocks may be something between 6 and 24, 30 megahertz. So it's not a lot, but you cannot get all these signals in a modern PC. The easy proof of that is that when we simulate the FPGA logic inside the computer, when we are developing, that's like the PC using the code, like as though it was an emulator. And that typically runs maybe hundreds of times slower than real time. So it's just that the power is not there. If you were to do this on software, you just cannot do that in real time. Even if a software could simulate the digital logic, which is what we do when we manufacture an ASIC, an integrated circuit nowadays. We use software simulators of the digital logic that are slow, and then we use FPGAs to prototype the same circuit, and that's way faster. Maybe it is not as fast as the final chip, because maybe the final chip is going to hundreds of megahertz and you cannot get that speed. But you are going to get hundreds of times faster in the FPGA than you can in the software.
So FPGAs will always, at least in the world that we're in right now, will always be more accurate and will be faster. And they are simply better. Like, is that a fact? It is just always going to be a superior way to try to maintain history in this way.
I think so, yes, because you can't describe all the logic exactly as it was. You are not describing a software. You are describing what was on the board.
So on your Patreon, you ship cores, and this word core has been confusing to people who aren't programmers because they're not really sure what they're being shipped. Like, what is a core? Is it a piece of software? It's not an executable? It's not a DLL?
Yeah, I don't know who came up with that name. It's not how FPGA manufacturers call these files. I don't know. But the files that people get are just a stream of bits that will toggle the switches inside the FPGA. It's basically that. It's not any software. It's not like any sequence of instructions. It's nothing like that. It's just configuring switches on and off.
So a core is not a little virtual machine. A core is not a series of instructions. It's just a state. And it's almost like a save state for a game, except it's a save state for the FPGA board.
Yeah, exactly. That's what it is. It is a static thing. It's just that when you power it on, that static configuration is a real computer or a real arcade game.
Okay. So I use an Analog Pocket, which I just have found to be one of the most amazing devices that I've purchased probably since the iPad. And it looks like a Game Boy, and I recommend it to anyone who's interested in this kind of work. But I'm curious, if you're going to be saving the state and loading the state rather, and basically changing the personality of this device multiple times, does it have a limit? Can I do it 1,000 times? Will it wear out? Can you change it unlimited number of times?
I think that the technology it uses is not flash memory. I think it uses just regular flip-flops, which means that there is no limit to the number of times you can program it. And it also means that when you turn it off, the state goes away.
Interesting. Okay, so it is waking up as an array. You load the state. It becomes a new kind of chip. It's day. It starts its work.
Yes.
On your Patreon, you release not just cores like today, January 5th, when we are recording this, you released the Neo Geo Pocket beta core, which has been, everyone's excited about this because people didn't think it was possible, and they were saying, when will it ever happen? The beta's out. It's very exciting. But I've also seen you release a game-specific one for a specific arcade. Help me understand why you would release a core for a console, but then some games need their own. Is that because there's an arcade board? It's a physical piece of hardware you're trying to...
Yes, because in the arcade industry, they didn't tend to reuse hardware. Like most of the time, they made the hardware specifically for a game. And then for the next game, they changed something. Sometimes the changes were small, sometimes the changes are really different. So there was little reuse in the hardware front. They were kind of reusing the same ideas over and over, but you have to make like a new hardware description of that and test it again and everything. And yeah, so it's a lot of work for a single game most of the time, where for a console you get much more use for the same effort.
Yeah.
Yes.
So that hardware description, that HDL, is the thing that you're coding in, right? You're basically writing FPGA configuration with the hardware description language. Does someone ship you the board, or are you looking at old PDFs from the 80s? How do you make your description match reality? I'm imagining you with an oscilloscope and a soldering iron trying to recreate.
Yeah, sometimes it is like that. Like I try to avoid that as much as possible because it's very time consuming. So if we can get like original schematics or original data sheets describing everything, that's the best scenario. But then there is always the case that some piece of information is missing because it was proprietary or because it just lost. And in those cases, what we typically do is we try to extract those schematics, whether it is from the PCBs or it is from the chips itself, like the cap in the chips, taking shots of the chips and extracting the schematics to really understand what the intention of the design was.
It's almost like archaeology when Indiana Jones is taking his like brush and he's just gently brushing the dust off of the bones to figure out what's going on. Did you ever have to call any of the original people? I assume they're in their 70s or 80s now. Have you ever called like the guy that went and did asteroids? And what were you doing here, man?
Yeah, no, the most I have done, I have exchanged a couple of Twitter messages with Yoshiki Okamoto from Capcom, who made a number of arcade games. He was involved in Street Fighter 2. I asked him once whether he thought my board was original or not. I have a Capcom board that says made in Spain, and I thought it was original, but he thinks it probably isn't because he doesn't recall having manufacturing here. So the thing is that most of these people are not working in the original companies anymore. And these companies have actually lost these materials. It's like I have been in conversations with some of these companies and they don't know. Even if you try to license from them so you can publish using their name, they tell you to go figure out because they just cannot help you.
Well, that brings up an interesting question then. What is the legality of work like this? Because you're not shipping games, you're not shipping ROMs, you are looking at a thing and making another thing. Like if I were to find an old Honda little car, I could make my Honda from original parts and 3D print them, and like it would be a recreation of the Honda just by simply observing it. You're not doing anything other than observing an object. I assume that's legal?
Yeah, so, well, it depends on the country. Like in the United States, what I have seen is that like there are several cases where it has been failed that it was legal. Like a famous one is the one of Apple versus Sony about a PlayStation emulator. And as long as they didn't use the Sony's firmware, it was okay. There was a similar one of Intel versus NEC, because they had made like versions of their chips, and some microcoded instructions were very similar, if not identical, but then the judge ruled that that sometimes there is only one way of doing things, and it's an obvious way, and that it is okay to actually reverse engineer what the other people were doing, as long as you then make your own thing and not just copy. So I think that has been settled in the States. Like in Spain, for instance, it is illegal to modify a console so it will run with unofficial games. But we are not modifying a console, so we should be okay. Yeah, but it's very hard to find information about these things. Like I know, like there are companies that will crack open a chip for you and get the schematics and all that. And they do that. You pay a fee, and normally, like big companies actually do this to know what the rivals are doing. But what you can do with that information is not that clear to me. I mean, you can probably use that you can use that to build your own thing, but can you polish it? Maybe you cannot polish it. Maybe you have to keep it in a drawer and you just inform yourself.
So you got interested in the MiSTer project, but I assume you had a job before you decided to make this your job. Help me understand the transition from whatever work you were doing before, your interest in this space, and then now you have your Patreon and then a couple of people working with you, and you've turned it into a little business of sorts.
Yes. So I actually still keep my old job. So I am a microelectronics engineer working for a big firm, like designing chips. So that gives me the background in understanding all these electronics. And what I did, like I think that the Patreon like makes a lot of money, but not enough money to pay for an electronics engineer salary. So that's one reason I cannot hire a real engineer. But I have been able to hire 2 people who help with things that they have learned, how to do. So it's very helpful. And if more money came from Patreon, I would probably try to hire an engineer rather than me quitting from my other job. And the reason is that there is a very good synergy between the 2 jobs. Like one is like leading edge ASIC technology, all the microelectronics from the 21st century. And the other one is like the opposite. It's like the electronics from 40 years ago. And I learned stuff in both jobs that can apply to each other. And in my day-to-day job, I get to talk with, very smart people that know a lot of things. Whereas if I was working on my own here, maybe after a while, I would just be talking to myself and,
I can relate to that a lot. Like in my day job, I'm working on like C# and .NET, and they're doing really cutting edge stuff on, brand new processors. And then on my desk here, I've been building this Apple I computer on a breadboard. And you'd think that they're not related, but they do somehow scratch 2 sides of the brain from the opposite direction. And it's healthy to have both of those things.
Exactly.
So on the Patreon, which I'm a member of, and I encourage folks that have a MiSTer or an Analogue Pocket to join as well, you give basically early access, like we mentioned today, that the Neo Geo Pocket Beta Core is out, and you allow us to beta test. But then you still eventually let them go through this process, this pipeline, until they get released to the outside. Have you found that to be a good way to make this financially sustainable and allow you to have those young people working for you? Because you're basically charging people for early access, but the code is still open source.
Exactly. Yes, that's one of the few working models of an open source business is early access or specific features or specific builds. That's what you can do, because if you directly just polish everything, like people just don't value it, and they will not even talk so much about it. Like the fact of having the focus on one thing at a time, it also makes people value these things more and enjoy them more. Like if you give them, all the games in the world or tomorrow, then they will say, okay, great. They will download everything. They will not play to anything. So just having it little by little works well. So people enjoy them more, and it gives me time to work. And at the same time, the beta process also makes people join the Patreon, because they join the Patreon because they want to play to something specific, to a specific game. But then they stay in the Patreon because they enjoy the posts, they like the work that we are doing. So they are getting value from that too. But eventually people who are in retro gaming or retro computing want to have this being available to everyone because they value the side of the archivist, the preservation side. So they do not want you to keep the source closed. And I appreciate that too. I am the same, so I like publishing what I do too.
I want to welcome Partner Hero, the Hanselminutes sponsor family. They provide customer service outsourcing that's built for the needs of scaling and high-growth startups. Partner Hero offers flexible terms, fast onboarding, and the ability to scale teams quickly, which is perfect for fast-growing businesses. In my experience, outsourcing tends to have a bad reputation as being exploitative and low quality, but Partner Hero's values-based approach will raise the bar for the outsourcing industry by investing in employee empowerment and focusing on career growth. They pay above-market salaries, and they maintain a focus on quality and performance. They also offer these flexible terms for you to scale quickly, which is perfect for startups. They bake quality assurance into every program, and they have offices around the world, so they can provide a truly global coverage. That means onshore, nearshore, and offshore. Outsourcing has long been available to big enterprise businesses, but Partner Hero is challenging the business as usual and bringing those benefits to startups. Short, flexible contracts, fast ramp-up times, values integrity, and expertise. If you're ready to bring in outside customer support help for your startup that feels like it's a part of your existing team, check out Partner Hero. Head on over to partnerhero.com/Hanselminutes. You can book a free consultation with their solutions team, mention you heard about Partner Hero from Hanselminutes, and they'll waive the setup fee. So I work in the open source space where I, as an engineer, work with other engineers. I'm sure that there are FPGA enthusiasts, there are engineers, but I think it's probably fair to say that amongst your audience, the majority of people are technical in that they can copy a file from here to there, but that's probably as technical as they get. And I have noticed that some of them can be a little bit aggressive about what their expectation is. Particularly, of course, with open source engineers, people want it now, they want it for free, and they want you to be up at 2 a.m. because they found a bug. Have you found the community to be friendly or to be aggressive or a little of both?
Yes, most of the time they're friendly. And you can really feel here that in open source development, a scarce resource is the developer. It's not the code. You have plenty of code, but there is only like one developer. So, and you gotta get this person's time and this person's attention. And they always try to get your attention and, can you please work on this, work on that? I want to play this or that. And yeah, that's good. That's a good indicator of, what can be interesting for the community. Then you also get a lot of questions. And one of the people in my team is actually in charge of answering these questions of, how do I copy this file? Why is this not working? And it's always the same questions. And the person who is answering them is not even technically, like we just have a template and then we can reply these questions because, they are important for them and they see, and that's one of the value points in paying for them that they can ask that question.
One of the things that I think is great about your Patreon, and I'm a sponsor of several Patreons, is that you don't spare the detail. In your posts, you tell us all this information. It's not just like a one-liner, I'm working hard, the core will be done in a week. You have, just for today's release, detailed bullets with game compatibility and even some acronyms that I don't know and some details on a Toshiba MCU. It seems like people really appreciate that they can see the work and that you're doing that. Did you know that that's what people wanted, or is that just how you're wired yourself to give all this information to the folks?
Yes, I think it's a lucky coincidence that, yes, I'm wired that way, and that seems to work well with people. Other people in the scene also have patrons, have a different attitude, and they prefer not to bother much with the patron. That they say, well, if people want to pay, they can pay, and I appreciate that, but I don't want to be pulled, away from what I'm doing or thinking or spend too much time there. But that I have to make the people in the community, feel special and give them something because they are spending time with us there. So I try to show that in the posts. On
this Neo Geo one, the Neo Geo Pocket that just came out, one of the things that I noted and I don't think you meant it to be funny, but I chuckled, was you said, of course, this is the beta, so only the monochrome version is going to be supported in this release. The color BIOS is not ready yet. And then a little bit later, you say, the hard part is over. The items listed above should not be that complicated, including adding color. And I laughed at that because I was just like, how is going from black and white to color is like, oh, it's just code. It's just trivial. But you've accomplished something in that you've got the bones here. And I love that you are so confident that adding color is going to be like, yeah, no problem.
No, that's going to be easy. Like the hard thing here was the CPU, because just reading the manuals, it's hundreds and hundreds of pages. And you have not maybe close to 300 instructions in the CPU. And the thing with the CPUs is that you get one little wrong and everything just stops working in an odd way. Because yeah, you can imagine, like in software, like the carry of an addition can break anything, like from your video to your audio to anything.
It's off by one errors, right? It's all about that off by one error, the hardest thing in software.
Yeah, and it's amazing that we have all this technology working, in our phones, in our computers, and everything could break with just a single bit going wrong, and it doesn't happen. That these things are so reliable that even that single bit doesn't fail.
And this one here, this Neo Geo that we're talking about, came out in 1999. So this is now a 25-year-old CPU. It's a TLCS 900H. It's at 6 megahertz, 6.144 megahertz. But this is still is this a 32-bit processor? This is no slouch. It's got a lot going on.
This is decent. It can do. I mean, that would be better than the CPU in a Commodore Amiga. Like they were sharing the same era, right? Like you could buy both machines in that year. This was showing that miniaturization was, taking place, and you could get all this. It's a very convoluted design, that CPU. Like you can see the two trends in CPU design, the RISC and the Cisk, going happening at that time. Because at the same time, we also had like the DSP chip in the CPS2 games, in Street Fighter Alpha and all these games. And that is a RISC CPU that has much fewer instructions. The instruction encoding is like very clear, and it's also very powerful. Whereas this one, oh man, I mean, this CPU is like a spaghetti bowl.
Yeah, this is really worth pointing out for folks who might be a little bit younger or may not be familiar with those words. You're saying RISC and Cisk. So Cisk is complex instruction set, which is ironic because it's literally saying in the name, we're complex. So you just pointed out that the Neo Geo Pocket has a complex instruction set, over 300 opcodes. And then RISC is like the exact opposite. It's a philosophical disagreement in the CPU world of like, should we make it do a lot of little things really fast? Or should we just make it do like the kitchen sink, the Swiss Army knife, a million different little things? And in this case, not only is it a Cisk processor, but you pointed out the architecture is weird. It's got 32-bit registers, a 24-bit address bus, but then the data paths on some of them are 16 bits. So they can't decide how wide the street is going to be. Is it 4 lanes? Is it 2 lanes?
Oh, and yes, yes, this CPU. Yeah, I don't know, these people in Toshiba, I'm sure that some people had a hard time in Toshiba too with this design.
Yeah. Well, you did it though, and congratulations. Was that the core that was like the most tedious so far?
Yes, it has been it's also that I didn't have an emotional attachment to this machine. Like I didn't know the machine before. So it always helps, if you have some kind of memory of the system, or if you have heard of it before, but I didn't know anything about it. And I just saw a screenshot and I thought, oh yeah, this must be serious. It's just like black and white, and the sound it's like a Game Boy sound. This must be something easy to do. But of course, I didn't know about that CPU.
Yeah, I think that is interesting, though, that you call out you have to have an emotional attachment. If it's something you played when you were a child, you would be like, yeah, I'm going to make memories here. But this is just for you in this case, wasn't a device that you grew up with. But you noticed in the community, people really love their Neo Geos. And the Pocket is like, people didn't think it was possible. And in this case here, you made it fit on a MiSTer and in an Analog Pocket. But some of the smaller FPGAs, this is too big. This beta core is too large.
Yes, and that's because of an architecture decision that I took. Like in CPU design, CPUs are like are a machine that you can program, and everybody knows that, right? That just sends instructions to it. But what many people are not aware of is that there is like a second level. That inside the CPU, you actually have like another, let's say, small CPU that has its own code. And that small CPU inside running its code is kind of emulating the big guy. And that's the way like CPUs have been designed in almost all cases. And that the software inside the CPU is called Microcode. Now, this was especially important. Well, it was important in the 70s and the 80s because the microcode simplified the logic. And because people didn't have software tools to help them in the digital design, being able to use this microcode, which is kind of software, make the design easier, and it almost made it possible. It's very important nowadays too, because in modern processors, they have so many instructions and so many functions that it's like the only way to make things reasonable. But using, modern day hardware description languages, you can do like the old CPUs without microcode. You don't need to resort to that. But it is still easier if you use the microcode. So if I haven't used the microcode, then it would have fit in small devices. But because I have gone for the microcode solution, which is what the original was too, then it doesn't fit.
Well, it's a huge accomplishment, and you should be very proud. We're excited. I'm excited after this call to try it out. Folks can check out all of your work at patreon.com/JOTEGO, JOTEGO. And if you just go and Google for JOTEGO, you'll find all of your great work, both on your GitHub and on your Patreon. I encourage folks who are doing retro computing to support you and your team and your work. Thank you so much, sir, for your time.
Thank you. Thank you very much, Scott.
Yes, absolutely. I can't tell you, my friend, gracias por su tiempo y su trabajo. La comunidad te aprecia.
Muchas gracias.
This has been another episode of Hanselminutes, and we'll see you again next week.